In this particular video, we're solving Newton's forward difference method. Interpolate the value of y when x is 1998. So first we'll know the definition of what is Newton's forward difference method. So Newton's advancing difference method, also known as Newton's forward difference interpolation, is a numerical method used to find a unknown value between two given values using the data points are equally spaced. It works best when the required value is near the beginning of the data. And in this method, a forward difference table is formed, and these differences are used to construct a polynomial equation that helps estimate the unknown value. This is leading difference table. So now x is years, and let's consider y as sales. So now for the given values, let's name it as y0, y1, y2, y3 and y4. And here on the other columns, we have to find delta 1, delta 2, delta 3 and delta 4. So to calculate delta 1, that is first order difference, y values are to be considered. From second value, first value has to be deducted. That is 84 minus 47, which is 37. Then third value minus second value, which is 105 minus 84, 24. Then fourth to third, that is 111 minus 105. Then same with fourth difference. So now let's name these differences as, for the first, delta 01. For second, delta 1 and 1. Delta 2, 1. And delta 3, 1. Small correction has to be done here, which is it is 21. Now for delta 2, we use the same formula, that is we subtract from second to first, that is 21 minus 37 is minus 16, then we get minus 15, then 3 minus 6 is minus 3. So this is delta 02, delta 12, and the last one is delta base 2 of 2. Similarly, we do this even for delta 3, 15 minus 16, that is 1, and minus 3 of minus 15 is 12. Delta base 0, 3 of delta base 1 of 3. Then here we get 11 base 0 and of 4. Now using these differences, we'll calculate the sum. So the formula of Newton's advancing difference method is yx is equals to y0 plus x of delta 0, 1 plus x of x minus 1 divided by 2 factorial and plus x of x minus 1, x minus 2 divided by factorial 3. Then delta base 0, 3. Here it continues, so plus x of x minus 1, x minus 2, x minus 3 divided by factorial 4. So delta base 0, 4. So this is the formula of Newton's advancing difference method. So to calculate this, first we need to know what is x minus 1. For that we need to find x first, then we can subtract that with 1, 2 and 3. So to find out x is equals to x1 minus x0 divided by h. H is the difference here. So in the question they have already given x as 1998 minus x0 is, from the question if you see, the first is 1996. So h is the difference of the x, that is 4. So here 1996 divided by 4, that is the difference of the years. So the answer we get is 2 divided by 2, that is 0.5. So what we have to do from this is we have to find x1, x2 and x3. So simply we need to calculate, that is x minus 1, which is 0.5 minus 1. We get answer as minus 0.5. Now for x2, 0.5 minus 2 minus 1.5. x3, 0.5 minus 3. We get is minus 2.5. So now we have got all the values which can be substituted in the formula. Here we have yx. X is 1998 as given in the question. And y0 is 47. Here you can check the table beside. And x is 0.5. Then delta 0, 1 is 37. Now plus x as it is 0.5. Then x minus 1, as you know, we got the x minus 1 as minus 0.5 as we did before, and divided by factorial 2. A small correction to be made here, I'm so sorry for that. Here it is delta 20, which is minus 16 in the question, plus x 0.5 of x minus 1 is 0 minus 0.5. Then x minus 2 we got as minus 1.5 divided by 3 factorial. Then delta 03 is 1 plus x is 0.5 again, x minus 1 0.5, x minus 2 minus 1.5, x minus 3 is minus 2.5 divided by 4 factorial. And how to find out factorial, we'll know that. So factorial of 2 is 2 into 1, which is, and then factorial 3 is 3 into 2 into 1. Then factorial of 4, 4 into 3 into 2 into 1. So multiplying 2, 6 and 24. Here it is 11, which is delta 0, 1. We have to multiply this. Now let's solve the sum, which is 47 as it is plus 0.5 into 37 multiply 27, which is 18.5. Then plus 0.5 multiplied with minus 0.5 divided by 2 factorial, which is 2. So the answer we get is minus 0.25. It is 125. Yeah. Then 16 minus 16 as it is plus 0.5 into minus 0.5 into 1.5 divided by 3 factorial, which is 6. So we get 0.0625. Then into 1 plus, if you multiply this, and the factorial of 4 is 24. So if you multiply it, we'll get minus 0.9375 divided by 24 and 11 to be multiplied later. So we'll write 47 as it is. Then what all we need not multiply, we'll write it as, if you multiply this, you'll get 2. Then we need to multiply this, we'll get the same answer. And then if you divide this with 24, you'll get the answer as, and even if you multiply it with 11, the total answer will be 0.4296. So here we got the answer as minus, so we need to subtract that last part. First we'll add, then subtract. So 47 plus 18.5 plus 2 plus 0.0625 minus 0.4296. The answer we get is 67.1329. So the final answer is 67 units. So as asked in the question, to find out x for 1998, which is So we'll write it here. Therefore, sales in the year 1998 is 67 units.